All right, we'll get started here. Hello and welcome to the next installment in this webinar series about how engineers in the various disciplines can benefit from cloud computing. And today's webinar is specifically about how Abaqus users can benefit from the cloud. My name is Thomas Francis. I'm head of products for UberCloud. UberCloud helps engineers, scientists use cloud computing to excel in whatever their chosen field is. Now, why is cloud computing important to you as an FEA engineer or an Abaqus user? To answer this question, we'll just take a short 2-minute history lesson and look at the various industrial revolutions that have taken place and draw a couple of insights from this before we jump into the nuts and bolts of today's webinar about how cloud computing specifically helps Abaqus users. This picture is about the story of the industrial revolutions that have taken place over the past 300 years. So back in the 1700s, the theme of the first industrial revolution was mechanization. And this revolution was powered by steam and coal. There were railways, cotton mills, and this was really the first mechanization of labor. And then in the 1800s, the second industrial revolution, which is the age of electricity. So there's electrically powered mass production. So the concepts such as specialization and division of labor were characteristics here. And you saw steel mills and factories. The third industrial revolution was one that most of us have lived through. And this was the computing revolution. Here the key technologies were transistors, microelectronics, and concepts such as Moore's law. And this was characterized by cheap computers. Now, finally, we're in the middle of a new revolution, and this is the data and intelligence revolution, and this involves the fusion of the online and the physical worlds. So you see technologies such as IoT, Internet of Things, artificial intelligence, smart manufacturing, augmented reality, virtual reality, etc. Now, the key insight about these revolutions is that the pace of these revolutions has been quickening. In addition, each revolution also builds on the technologies of the previous one, and really it commoditizes the technologies of the previous revolution. So if you take an example of the computing revolution, when that happened, it didn't make sense to generate your own electricity to take advantage of this computing power. Instead, what you did in the computing revolution was you looked at electricity as a utility, and you just consumed it as a utility. And that's the only way you could take advantage of all the new technologies coming out of the computing revolution. Similarly, if you want to take advantage of the technologies of the current revolution, the data and intelligence revolution, you have to really stop wasting time managing computing resources and look to consume them as a utility. And that's the only way to start doing some of the higher level functions that are being made available every day. So that's the little preamble here. And before I introduce our speaker for today, a quick reminder that if you have any questions during the talk, you can type them in the chat window on the bottom right, I believe it shows up. And our speaker for today is Ebru Taylak, and she'll talk about the specific challenges that Abaqus users face with regards to hardware and how cloud computing can help. Ebru is an engineer and an analyst with experience in computer-aided engineering. She's worked at companies such as Dassault Systems, and she's also an entrepreneur. Ebru's education includes a bachelor's in aerospace engineering and a master's in computer systems. So I'll turn it over to Ebru now.
Thank you, Thomas. Okay, so as Thomas said, I worked many years as a CAE engineer, and I know actually many of you in the audience today are also CAE engineers. So we all share the same experience. We know running simulations can be slow and painful. So in today's world, product design is driven by simulation, which means lots of simulations need to be completed to finalize a design. So as the number of simulations in the design process add up, product time to market takes longer, and this can easily translate into lost sales. So this puts lots of pressure on us CAE engineers. So we often make trade-offs. We simplify our models to make them run faster while keeping them accurate. And, you know, perhaps this might be straightforward for an experienced engineer to make this call, but not so much for a recent graduate just out of college. And we share resources with our colleagues, submit jobs on queues, wait for licenses to become available. And often we work on slow, outdated workstations. So even if you have the luxury of having an on-premise cluster, it might actually not be up to date with the latest technology. So all of these slow down our work, but also the product time to market. Before, HPC was available on-premise clusters, and these required expensive hardware, and these were expensive to operate. And not all scientists, all engineers could get access to HPC. So lack of resources held them back from innovation. But today, the world of HPC has changed. So today, engineering expertise is expensive. So there's huge demand for skilled engineers, but there are not so many in the market to fulfill the demand. And companies can't afford to waste their engineering resources, engineering time, sitting and waiting for simulations to finish. So to stay competitive, they need their engineers to be highly productive and innovate. On the other hand, computational power on the cloud, it has become cheaper than ever. So now engineers can efficiently use their time running more simulations and faster. Actually, for under $1 an hour, you can get access to powerful CPUs, GPUs that accelerate your simulations by many-fold. And technology is moving fast too. So IT can't keep up with the latest technological developments anymore, such as, you know, new GPUs, InfiniBand, and all the other advancements. And obviously, you don't want to miss out on the latest tech that will speed up your simulations. So as a result, at UberCloud, every day we see more and more engineers coming to us and asking us to take their simulations to the cloud. And we witnessed amazing new studies happen because best-in-line computational resources are finally accessible by everyone, including engineers, scientists who can't afford their own clusters. And we help them speed up their simulations and to innovate. So I'll tell you a story about this. A researcher for Stanford University, Francisco, he did not have access to the computing power he needed to run his analysis. So he was ready to make a scientific breakthrough, but unfortunately, lack of resources were holding him back. And I will tell you more about this in a few minutes. First, I want to share some studies with it. So here, if you look at the bottom left corner, so here we compared the total cost of ownership of HPC on the cloud for 1 year to the cost of ownership of an in-house cluster. And usage here was measured by a 20% utilization of a 256 core in-house system. And the study was based on IDC data. So what did we find out? We found out cost of simulation on the cloud is more than 72% cheaper compared to an in-house cluster. And that's great cost savings. And if you look on the right, so remember, I was just telling you that your 2-year-old in-house cluster might not really be as fast as you think. And this is a proof to that. So we compared simulation runtimes on a 2-year-old on-premise cluster, which was up to date with the latest technology at the time of purchase, and runtimes on UberCloud Azure environment. So both with the same number of cores. And here we found out that UberCloud Azure environment performs 53% faster, which is a great performance gain. So I want to move to some Abaqus benchmark data. So Abaqus, standard, explicit, CFD, they already perform well with parallel computing. So with the freedom to choose the right hardware configuration based on my analysis type and picking as many cores as I need, I can easily increase my performance gains even further. So this example we are looking at here, it's an explicit benchmark car crash model. And this has over 274,000 elements and 62,000 increments. So we did this analysis using Abaqus performance data, and it's a good demonstration of how you can speed up your simulations by adding in more cores. So here, if you look at the chart, comparing the run times of the analysis on 8 cores to 64 cores, our speed up is more than 4 times. Also here, we see that the average license token cost per core decreases from 1.5 to 0.43 on 64 cores. So that's more than 28% decrease in average token cost per core. And so again, picking the right hardware can save a lot of time and money. And Abaqus standard actually allows the use of GPUs for computing. And I can get up to 2 to 3 times performance by using GPUs paired together with CPUs. And GPUs also reduce consumption of licensing tokens. So this is a study by NVIDIA, and we are looking at a 4.7 million degrees of freedom nonlinear static model. And here, simulation on 16 cores uses 16 tokens. And when I add in 1 GPU, I can speed up my simulation by more than 2.5 times, and by using the same amount of tokens. Again, for 32 cores, by adding in 2 GPUs, I can speed up my simulations by 4 times, and by using only 1 extra token. So this is great performance gain and great cost savings. So by taking Abaqus simulations, which already perform great with parallel computing to the cloud, I can further speed them up by getting access to the latest hardware, adding in more number of cores, and additionally, by getting instant access to as many cores as I want, I can run as many jobs as I want in parallel. So this will help me to speed up my whole design process and bring also my products fast to market. So I can speed up my simulations, I can bring my products faster to market, I can save my company lots of money, but that's not all. So in addition to all of these, simulation on the cloud can be a pleasure to use experience. So as an example, let's look at the UberCloud experience. So once I sign up, I receive a welcome email that has my login information in it. And now actually all I need is a web browser and an internet connection. So I click on the link, enter my password, and I'm on the cloud. It's that simple. So here, what you see on my screen, I'm looking at Abaqus Viewer. I have some simulation results here. And as you see, it just looks like your regular desktop. So the graphics on Viewer, they are really nice and clear. And so the best thing about this, in my personal opinion, is I don't have to change my existing workflow. There is nothing new to learn. So I can just continue working as I was already doing. So I can use Abaqus CAE for post-processing, for pre-processing, for submitting jobs. Or if I want, I can use a terminal window to submit my jobs and even run my existing Python scripts to post-process some results and generate some reports. And additionally, I can easily get new software installed, perhaps I want to start doing optimizations using Abaqus with iSight, and I can get iSight installed here in my compute environment, and I can start using it immediately. So I want to show you a screen recording I took from my personal laptop. And I remember, so back in the day, I had to drive to work late at night, even sometimes as late as 10 p.m. to review my simulation results so that, you know, I could submit new jobs overnight. And this was kind of frustrating. But today, thanks to the advancement with GPUs, remote visualization technology, I can actually view my results from anywhere, anytime. So here, what you see is an Abaqus example problem, simulating the collapse of a stack of blocks, assuming one block was removed just before. And as you see yourself, this is simply amazing how far this has come. So cloud simulation has huge benefits for engineers. So first, I will have confidence in my analysis. I don't have to do trade-offs anymore. I can run simulations fast while using more detailed models that capture the realistic behavior accurately. And then I can get a dedicated cluster. I can get it configured based on my requirements and add in more computing power instantly. And by speeding up my simulations, I will bring in my products faster to market. And cloud has global accessibility. So it can be accessed from anywhere to run jobs, post-process results. And my colleagues overseas can access my licenses when I'm not using them. They can even access my compute environment and review my results, which is great for collaboration. And I can always unlock new capabilities. As an example, if I want to run a new study, new optimization study, I can get easily new software packages installed and start using them instantly. So now let's look at some case studies. So we have conducted many case studies and experiments by partnering up with scientists and engineers worldwide. Today, we have more than 4,000 community members. And you can get access to these case studies on our website. And also, you can get access to over 200 experiments once you join our UberCloud communities. So now I want to get back to Francisco, the researcher from Stanford University. So I was telling you, he didn't have enough compute power for his research. And we actually provided him with a 160 core cluster on the cloud. So he was able to complete his research and publish it. And Francisco told us that this project would have not happened if he didn't get the compute capacity he needed. So using HPC on the cloud, Francisco was able to run realistic human heart simulations. So these simulations were identifying the arrhythmic risk of existing and new drugs. And so this study was conducted by using Abaqus. If we look at his model information, his heart model had 7 million elements and 250 million internal variables. And it took him 40 hours on a 160 CPU core to complete one simulation with a speed up by a factor of 27. And he had to run 42 of these simulations. So here is another Abaqus case study. And this is for heavy-duty structural analysis. It's for cast-in-place concrete anchorage pull-out capacity analysis. And this was conducted by Frank, an engineer at Simpson Strong Tie, and study was sponsored by Intel. So his model had more than 1.5 million elements and 2 million degrees of freedom. So because of the large model contact and damage failure procedure that were involved, parallel computing had to be employed to speed up his solution process. And as a result, the analysis was completed in 11.5 hours on a 32-core Linux cluster. And full access for remote visualization of the simulation results was available throughout the analysis. And last but not least, here's another case study for life sciences. And actually a paper about this was published recently. So here, scientists at National Institute of Mental Health and Neurosciences in India, they were able to simulate the non-invasive neurostimulation of the brain, another breakthrough. And this model had more than 1.8 million elements, and the simulation had a speed up factor of 2 on the cloud. And it was running 28 minutes on 24 cores. Again, full access to the model through remote visualization was available throughout the analysis.
All right, great. Thank you, Abru. So let's recap here. As we said, we're in the middle of a fourth industrial revolution, and the possibilities are really exciting. There's a lot of new capabilities that are being made available. But to take advantage of some of these tools, you need to change a few things. You really need to stop wasting time managing computing and really consume it as a utility, just like you do electricity, so that you can focus on the higher level work. And cloud computing is a great way to offload some of this low value IT jobs, and you can do this in a secure and scalable way now. Ibra, could you just move to the next slide? We'd love to hear from you. Come tell us about the challenges that you face when running Abaqus, whether it's hardware shortages or inability to use GPUs, etc. You can benefit from our case studies, best practices, and benchmarks, and you can get your trial account here. So at this point, I'd like to start answering some questions if there are questions. I saw one come in earlier about licenses for Abaqus in the cloud. So at this point, it's really bring your own license. So if you have a Abaqus license already, we can make that available in the cloud for you. So that's the primary method. Any other questions? Any comments? So we have a question here about the Abaqus software. Is the Abaqus software itself on the cloud? Yes, it is. So all you would need to bring is the license tokens. So the installation, the management of the software, version control, all of that is handled by us in the cloud. So yeah, it'll be available in the cloud. Essentially what you would get is a login and password. Click on the link and suddenly you're able to access Abaqus through your browser in the cloud, yes. Okay, so there's another question here about, is there a cost to bring licenses to the cloud, or is it a straightforward process? There isn't any cost specifically to bring the licenses to the cloud, but there is a cost to the Abaqus platform, the UberCloud Abaqus platform. And just ping us and we can talk about your specific needs and how that would work. So essentially the way our platform is architected is these are really issues that you should not worry about as a researcher or an engineer. You don't, these are the low value IT activities that I mentioned. And that's really why UberCloud exists, to abstract all of that unnecessary sort of plumbing and piping from you so that you can really focus on your high-end activities. Do we have, here's another question, do we have access to different versions of the software, say 2016, etc., on the same account? This is a great question. This is one of the huge benefits of cloud computing. Yes, the answer is absolutely. You can have access to multiple versions of the software. And the reason we're able to do this is because of the flexible nature of cloud. So in cloud computing, in an on-premise case, say you have a cluster, well, you have to run the same software on the whole cluster. That's the only way to manage it, is standardization. And in the cloud, you have the opposite. You have flexibility. So I can give you just one person, this question was asked by, I can give you 3 different Abaqus setups as long as you're licensed for them. I can give you one with 2016, another one with 2018. So I can give you 3 different setups that you can use simultaneously and then shut them down when you're done. So there's, it comes with a lot of flexibility in terms of licenses and versions, etc. Okay, one more question. How long does it take for me to get on the cloud in my Abaqus environment? Yeah, this is a good question as well. It's unbelievable how short that time is, especially if you've gone through a procurement process of buying not just clusters, but even workstations take weeks. And installing a cluster is a many-month activity. Well, here it's a matter of hours or days from when you have the need to when you can run it. So some of our customers just let us know overnight that they need a large cluster, and we can make that available. So you can measure this time in hours versus days or weeks. All right, any other questions? About 30 seconds left. Okay, another question here. If you have a model, but we're not sure what computer configuration is optimal, say CPU numbers, speed, number of cores, etc., do you provide a test run to find a sweet spot? Another really great question. And this is, again, a huge benefit of cloud. I think the audience is recognizing the specific advantages of using cloud computing. Yes, we can help you benchmark those. And in fact, this is one of the important services that UberCloud provides, is we help you understand price performance. So for the first time, you now have the ability to say, I have this workload that's really, really critical. So I'm price agnostic. I just need to get it done fast. Tell me what you can offer. And the next day you can come back and say, I have this other workload that I don't really need to be done quickly. So give me the best price for it. I don't care how long it takes. So you can ask these kinds of questions, and we can help you think through price performance, which is really the metric you should be paying attention to in the cloud, because of the extreme flexibility that I mentioned. Okay, great. I think we are at the end of our time here. And again, we're really interested in hearing about what challenges you face today. We already had some great questions about versioning, about types of CPUs. Just come see us on our website, and you can get your trial account to try this out, and you can learn more about this topic. So with that, I'll thank you all for joining, and I hope you enjoy the rest of your day.